A very good afternoon to all. I am Shalini Singh, Assistant Professor, Computer Science Department, ABES Engineering College, Ghaziabad. Today, we will discuss equivalence of functional dependency. Now, there is a question arise, how to find the relationship between two functional dependency sets. Now, as we can see, let us suppose if we have two functional dependencies, FD1 and FD2, for a relation R. If all the functional dependencies of FD1 can be derived from functional dependencies present in FD2, then we can say that FD1 is subset of FD2. In the same manner, if all the functional dependencies of FD2 can be derived from functional dependencies that are present in FD1, so we can say that FD2 is subset of FD1. And if both the above two cases are true, then we can say FD1 is equivalent to FD2. Here we can see in the diagram all the three cases present here. Now, there is a question why we need to compare the functional dependency. Let us suppose in a designing process, we convert ER diagram to a relational model, and this task is given to two different engineers. Now, those two engineers give two different sets of functional dependencies. So, you can say, being an administrator, we need to ensure that we must have a good set of functional dependencies. And to ensure this, we require to study the equivalence of functional dependencies. Here are the advantages. It can help to identify redundant functional dependencies, which can be eliminated to reduce data redundancy and improve database performance. And it also helps to optimize database design by identifying equivalent sets of functional dependencies that can be used. Third advantage, it can ensure data consistency by identifying all possible combinations of attributes that can exist in the database. Now, these are the disadvantages. As we can say, the first disadvantage that the process of determining the equivalence of functional dependencies can be computationally expensive, especially for large datasets. The process may require testing multiple candidate sets of functional dependencies, which can be time consuming and complex. And the last one, the equivalence of functional dependencies may not always accurately reflect the semantic meaning of data and may not always reflect the true relationship between data elements. Here, with the example of this question, we can show how to calculate equivalence between two relationships. Here, two functional dependencies are given. You can see in FD1, we have certain set of dependencies, while in FD2 also we have certain set of dependencies. As we can see, A to B, B to C, AB derives D, while in FD2, these are the set of dependencies. So, in step 1, we will check whether all functional dependencies of FD1 are present in FD2. So, the first dependency, A determines B. We need to check for this. In set FD1 is present in set FD2. After that, we need to check for second functional dependencies, that is B determines C, in set FD1, and it is also present in set FD2. For next functional dependencies, that is AB determines G. It is present in functional dependency FD1, but it is not directly present in functional dependency FD2. But we need to check whether we can derive it either directly or indirectly. For this dependency, we need to check for AB closure. When we calculate AB closure, we will get values A, B, C, and D. It means that AB can functionally determine A, B, C, and D. So, AB determines D will also hold in FD2. So, we can say all functional dependencies in set FD1 also hold in set FD2. So, FD1 is subset of FD2. It is true. So, we have completed step 1. Now, for step 2, we have to check whether all functional dependencies of FD2 are present in FD1. Now, here we can check all the dependencies that are given. So, A determines B is present in set FD2. It is also present in set FD1. So, it is true. It satisfies the condition. For second dependency, A determines C in set FD2 is also present in set FD1, as we can see in both the functional dependencies. Now, A determines C. This is also present in FD2, but not directly present in FD1. But here again, we need to check whether we can derive it or not. So for set functional dependency 1, we have to calculate the closure of A. While after calculating the closure of A, we get A, B, C, and D. It means that A can functionally determine all the attributes that are A, B, C, and D. So we can say A determines C will also hold in functional dependency FD1. Now, for next dependency, we have to check A determines C is present in both or not. So A determined D is present in FD2, but it is not directly present in FD1. Again, we have to check whether we can derive it or not. For set FD1, again, we will calculate closure of A, as we have already calculated the closure of A. So it consists of A, B, C, D, all the attribute. It means A can functionally determine A, B, C, and D. So we can say A determines D will also hold in FD1. As all the functional dependencies in set FD2 also hold in set FD1. So we can say FD2 is subset of FD1. This is also true. So as we have already studied that if FD1 is subset of FD2 and FD2 is subset of FD1, so we can say that FD2 and FD1 both are equivalent. Therefore, these two functional dependencies are semantically equivalent. That's it from my side. These are the references. Thank you so much.